Here we go again. Welcome back, guys, to this video. Today we're going to cover or finish or put the latest touch on the junior penetration tester track from TryHackMe. So basically we're going to cover the walkthrough of BurpSuite Repeater, BurpSuite other modules. Regarding BurpSuite Intruder and BurpSuite Basics, there are some updates on these rooms. You can check them out by visiting TryHackMe website. If you want a walkthrough for the basics and the intruder, you can check out the videos. I'm gonna put these in the video description. I covered the BurpSuite Basics walkthrough. In addition, I covered the guide to, or the complete guide to BurpSuite Intruder. And if you want to have a walkthrough for all of the rooms in the junior penetration tester track, you can find them in this playlist, which I'm going to reference in the video description. For now, let's get started with the BurpSuite Repeater room. We're going to go over the answers for these questions. Before we do that, let's use the attached machine, the attached attacker machine, and have a look on the BurpSuite Repeater. Specifically, we're going to talk about the various sections and what's the objective of using the BurpSuite Repeater, what are the situations in which we need to use the repeater, and at the end we're going to cover the extra mile challenge in task 8. With BurpSuite running, we can go to repeater by navigating through the upper tab in here. We click on the repeater and this opens up the web, or opens up the interface. As you can see, there is nothing in here. It's empty, and we have two panes. Left one, which includes the request, the HTTP request, and the right pane we have the response, where it will display the response to the request that we will send. So basically here, this is where we will manipulate or handle the HTTP request. Now, as you can see on this bar, we can control some settings, such as we decide when to hit the send. Okay, for example, when we have the request here and we click on send, the request will be sent to the web application or the target web page. Here are some other settings. We're gonna go over these in a while, and here we can cancel the request. If we hit send by accident, we can click on cancel to cancel the send of the request. As you can see here, guys, we have number one on this tab. So these tabs will be numbered depending on how many requests you have on the request section here. On the right, we have the inspector. The inspector will list all of the available parameters that are related to the HTTP request. Basically, we can modify the request parameters, the request settings, either from the inspector or from the raw view from here. As you can see, I have pretty view, raw, and hex. For the request, we will only have the raw and hexadecimal representation of the HTTP request. However, in the response, we'll be able to view the response to the request we just sent using 4 basic views: the pretty, the raw, hex, and render. The raw is pretty much straightforward without formatting. The pretty will put some formatting on the response. The hex will put hexadecimal representation of the response, and render will give a render view or a complete browser render view, as you see the response in the browser. Okay, so what are some of the ways we can use repeater to modify web requests? We can just copy paste the request from request, or we can send the request to the repeater from other sections, such as the proxy or the intruder. For example, let's go to the web page here, and the extension Foxy Proxy is very recommended if you want to turn off and on the proxy or the Burp proxy with one click. So we're going to click on Burp to enable the Burp proxy. Going to hit enter. Before we hit enter, let's make sure that the intercept is enabled. So we go to proxy and make sure that intercept is on. Go back. Now we're going to send a request to the web page. So the request now is hanging. We need to check this out from Burp. So now we have the request in the proxy section. Okay. Now I get to choose whether to forward the proxy, or to forward the request to the application, or to do some stuff with it. What are the operations we can do with this request? For this video, we're going to discuss, as we said earlier, the repeater. So we highlight this, we right click, and we select send to repeater. Alternatively, we can use the shortcut Ctrl+R. I'm gonna send to repeater, and as you can see, the repeater now lights. So we have the requests from here. Now, as you can see, the inspector fields have popped up from which we can manipulate or modify the parameters. In the request attributes, we can change the request method. By clicking on the row here, we can get to change the value from get to post or other type of HTTP requests. Here we change the path. We get to change the requested page. Here we are requesting the landing page of the website. Instead, if we want to change this, we can put the path or the URL of the requested page. Okay. Request query parameters. The query parameters are the queries that appear in the URL after the slash, such as you can see this very clearly in e-commerce websites or in websites which are connected to a database. That display rows and columns, IDs, so on and so forth. As you can see, we have numbers here indicating that the number of requests parameters that we can change. So here we can change 2 request parameters, here we can change 7, here we can change none of them. If we click on request headers, now here we get to change these headers, the HTTP headers, the host, the user agent. We can do that just by clicking on the arrow, and this will open up the name and the value. So the name here is host. Now this is the value, this is what we can change. Go back. Now this is one method of changing the request or modifying the request parameters. The other method is to do that manually. So from here we can change the IP address of the host, we can change the user agent by modifying this query, or even we can add headers, such as the headers shown in the extra mile challenge, I would assume. No, in the challenge, task 7. So in task 7, you're required to add a header, not this one, in the practical example, task 6. So in task 6, here, in order to get the flag, you have to modify the header, or literally you have to add a header named flag authorized. So if we copy this, and we go here, we paste this. Now, how to know, or how to find out what is the proper formatting of adding a new header? The answer is simple. You just have to follow the formatting shown here. So as you can see, the name of the header followed by a colon, and then we have the value. That's what you should do when you add a new header. So now we put colon and then the value. The value here is true. Okay, and now it's time to click send. So we click send, we can see the response. That's the raw response. And as you can see, this is the flag. If you click on render, now this is the browser render of the response. In very simple words, that's the purpose of using the repeater. We want to manipulate or want to modify the HTTP request as much as we want, while at the same time, simultaneously, we monitor the response sent by the application. We use this to test applications for multiple vulnerabilities, such as SQL injection, local file inclusion, and other web vulnerabilities. The repeater is very useful. Instead of just using the proxy, we can use the proxy to modify web requests, but that requires us to send the response back and forth, enabling the proxy on and off multiple times. Instead of doing that, we just capture the request in the proxy and we send it to the repeater. Here we get to modify and send as much as we want, simultaneously maintaining the seamless flow of the testing of the application. Now let's go to the questions. The first question, or task 2, what is a repeater? Which section gives us a more intuitive control over our requests? It is the inspector. It's more intuitive because every section is broken down with the corresponding parameters, the basic usage, which view will populate when sending a request from the proxy module to repeater. It is the request. So we have the request view and the response view. When we send a request from the proxy, a capture to request from the proxy, when it is sent to the repeater, it will first appear in the request and the response will be empty. When we send the request, the response will be populated in the corresponding view. Message toolbar analysis. Which option allows us to visualize the page as it would appear in a web browser? So in the response section, we control how we want to view the response. By clicking on render, we select to view the response in a render view. Inspector. Which section in inspector is specific to post requests? So in the request body parameters, we get to change the parameters of the request if it was a post request. Practical example, we already covered this. The challenge now. Okay, let's see the challenge. Enable and intercept again and capture request to one of the numeric products endpoints in the proxy module and forward it to the repeater. So we have this page. We're gonna go back to the proxy, make sure intercept is on. Check out the browser from here. Make sure the burp is enabled, the proxy, and then we hit enter. This is captured now in the proxy tab. Okay, now we highlight and we send to repeater. As you can see now, it appears on the repeater. But moreover, we actually want to, let's forward this. We want to capture a request sent to one of these products. So these are the products offered by the web page: the VPS, the managed hosting, the web design. Every product or every feature here corresponds to an ID shown here. So we click on see more. We go back to Burp. As you can see now, we have one, indicating that the VPS product is given an ID equals to 1. That's what we need to capture. Okay, so now we captured a request. I'm gonna send this to repeater. So now we have more than one tab, right? We're gonna manage the workflow by canceling all of the not needed anymore tabs. This one is not needed anymore. This one is not needed. That's what we need now. The one that sends a request to the products, specifically the product ID, which equals to 1. We want to trigger an internal 500 or 500 internal server error. How do we do that? So basically, now the application or the web page expects us to select one of the listed products: VPS, managed hosting, and web design. Every one of these products, as I stated earlier, corresponds to an ID, right? 1, 2, 3. So the whole application now expects a numeric ID here. 1, could be 2, could be 3, could be 4, could be 10, could be 20. Since there is only 3 products here, it means the application expects only one of 3 product IDs, 1, 2, or 3. So you have 1, we send, and we get a regular response. We click on render. Erase doesn't support Burp's browser running with its sandbox enabled. Yeah, we can't view the render here because of the settings connected to the machine here. But anyway, we get a regular response here. As you can see, it is 200 meaning the response is correctly handled by the app, and we get the product details. If we change this to 2 and we send again, we get another proper response, and we can see the details of the other product, managed hosting. Now we choose 3 and we get another correct response listing the third product, which is web design, as highlighted here. Okay, now we want to trigger 500 internal server error. This kind of error is triggered when you provide or supplement or supply an output, an input that is not expected by the application, meaning the application does not know how to handle the input. Here we control the input. Let's say we give this 1000 and we click on send. So what we get here is 404 not found. What does that mean? It means that 1000 as an ID is still an expected input by the user from the application, but there is no corresponding entry in the database for this ID. Okay, there is no product whose ID equals to 1000. That's why we got 404. So this is not what we want, but we are kind of one step closer. We want to choose an ID that is not expected by the app. Here we expect, the application expects numbers. If we change this to maybe symbols, if we put apostrophe, ampersand, and $, and we send, again we get 404. Okay, let's try this on the web browser, see what's going on. Gonna disable Burp and go to see more. So here we have the VPS product. This is the one, the ID one. If you put apostrophe and double ampersand and we click, we got 404. So the application can handle the symbols. Okay, let's go back. So what is another type of input that could trigger 500 internal server error? If we try the minus sign, maybe minus is 0, we click on send, again we get 404. If we try an ID equals to 0, we get 404 again. There is no product whose ID equals to 0 or minus 0. If we try with minus 1, now we get 500 internal server error. Okay, so what does that mean? It means that the product or the application doesn't know how to handle product IDs or inputs where there is minus sign beside the product ID. And by doing that, you get the flag for the task 7. Okay, now the last task, extra mile challenge, it is an SQL injection challenge. Okay, let's have the web page here. So we require to send a request to the web page about /2. So we're gonna check this out before we start the testing. So we click on about and we see the web page lists the team members of the company. If we click on one of these, such as the CEO, so we get here number 1. It means that the CEO entry in the database ID is equal to 1 or equals to 1. Oliver has an ID equal to, and that's what is required in the testing. We're gonna test this in the repeater. So first, we're gonna go to Burp, proxy, enable intercept back on. From here, we're gonna select Burp to enable the proxy, send the request to the Burp, and then go back to Burp. We have the request here. We're gonna highlight and send to repeater. So we're gonna click on X here to cancel the previous one, and now we only work with this one. Okay. So the assumption here is that this page or this the page here is vulnerable to SQL injection, meaning the database is supposed to be vulnerable to SQL injection. How to verify this hypothesis? We're gonna change the 2 with apostrophe. This is the standard testing for SQL injection vulnerabilities. You change the input or the expected input by the web browser with an apostrophe, and you send. Now we get 500 internal server error. It means that the application doesn't know how to handle the input we just sent. If we scroll down, we can see there is an SQL error, invalid statement, and this is the SQL statement that was executed by the application and passed to the database. So select first name, last name, PFP link, role, bio from people where ID equal apostrophe. Now this is the first time that the application, and specifically the version of the application, is vulnerable to SQL injection, meaning the application doesn't know how to handle the user input when it is not expected. The application, when a proper application or a secure application, should not return back SQL errors. We're going to take advantage of this and use it in an SQL exploit. So here, let's analyze this statement. These are the first name, last name, PFP link, role, bio. These are the columns belong to this table. The table name is people, and these are the columns. So there are 5 columns, okay? And here, another column, which is ID. So in total, we have 6 columns, okay? Now we are told that there is another column here, okay, that displays the notes of each of the team members on the page. So each team member has a first name column in the database, last name, PFP link, role, bio, ID, and notes. We're required to extract the values found under the notes column. So in total, we have around 7 columns. This knowledge will prove valuable when you test for SQL injection. So now we have the table name and we have the columns. Of course, there might be other columns that we don't know about. That's why first we want an SQL query that extracts all the columns. We're going to cancel the apostrophe. It served its purpose now. We know that there is SQL injection vulnerability, and now we go back to 1. Now we go back to a regular response. This is the response, corresponds to the entry of the co-founder. Okay. What if now, after the 1, here we put a space and we put a union all select statement. For union all select statements to work, they should be supplied with an invalid input. An ID that is valid. We want an invalid ID that would trigger an error. So 0 is a good choice. And then we paste in the union all select statement. So union all select is very useful when you want to extract all data from a database or from a table or column. So here we use union all select. And then we have this. Remember from the previous response that we had 5 columns. So what we're going to do, we're going to tell union all select first group concat column name. Here we extract all column names using the group concat, and then we have 4 nulls. So in total we have 5 columns here. So why 5? Because remember, when we send an apostrophe here, we saw that in the SQL statement there were 5 columns displayed. So in our union all select we have to use 5 columns here. So we select null. For the rest of them, we don't want any values returned. For the rest of the columns, we want to extract the name of all columns. That's why instead of using first name here, we use group underscore concat. And in between the parentheses, we use column underscore name, indicating we want to group all of the column names and return the values in one column here. When we want to extract the column names, we want to extract it from the information schema.columns. This is the table that contains all the relationships and the settings about the columns. That's why we choose it. Where table name equal to people. So from where we want to extract the column names, we want to extract it from the table people. And the database name is information schema.columns. This is a standard name. Okay, you can use it for all of these scenarios. Okay, so information schema.columns, it's the database containing information about the columns. of all of the other tables and databases. Information schema rows here contains the rows. Okay. Information schema.tables, instead of columns you put tables, you will get the list of the tables, and here you put table name. That's how it works. Unfortunately for this challenge, it requires a bit of knowledge in SQL injection before you are able to extract the flag. But here I'm trying to explain as much as I can and in very brief fashion. Okay, so after constructing the query, now we're going to send. Alright, let's see here. So take a look at this. So we get ID, first name, last name, PFP link, role, short role, bio, notes, none. These are the column names. And this is the output for the SQL query that we executed here. And this is all by virtue of the group underscore concat. Okay, if we put here first name and set send, as you can see here, what we get is 500 internal server error. Let's try with notes. And we get the same because this is not unexpected. Yeah, so here notes is not found from information schema.columns, so we have to modify this and we choose from people. Okay, now as you can see, when you corrected this, we have the corresponding value under the notes column, right? Now let's go back to the previous example. Now that we know the name of the columns, we can now think how to extract the values found under the notes. So notes is a column that belongs to the people table. We want to extract the values under the notes column. We want to build a corresponding SQL query for that. What we can do, we can keep union all select as is, and here we can change this. Instead of group underscore concat column name, we can choose, for example, first name. Okay, and then we have last name. Okay, let's now put notes. And we have to modify this from information schema.columns. We're going to remove this because we are no longer inquiring about the name of the columns. We're going to remove this, and we're going to remove the where and keep only people. So we want to extract these columns from this table, from people. We send, and we get a 500 internal server error. So why is that? Because we haven't specified the ID. Remember that every column or every entry in these columns correspond to an ID. The ID that belongs to the corresponding team member. So we want to extract the notes of the CEO. Remember, this is the CFO, I think. I'm gonna disable this. We want to extract the notes of the CEO. So we want to select ID equal 1. So we go back, we use a where statement, ID equal 1. We supplied 3 columns, and the formula states that we have 5 columns, so we're gonna use null for the other column names. And scrolling down, so indeed we have first name, last name, but there is no notes. Look at this, there is the flag. This is the flag, I guess. Yes, this is a flag that you find when you execute this query. Now if you change this to 2, As you can see now, the response changed. Now we get the first name of the CFO, Oliver Parsons, and notes, no notes. Change this back to lowercase. Okay, that doesn't matter. Right now we get the answer. So that was it for this room, guys. Now we're going to shift the focus to the other modules. So in the decoder, we get to change or make transformations on the data. Okay, much like in CyberChef, where we use CyberChef algorithms to change between base 64, base 63, ASCII, hex, all sorts of transformations that can be done on a sample of data. So here we get to choose, or we get to do the same with BurpSuite Decoder. So this is the workspace or the pane where we can input the data, such as tests. And on the right, we can choose how to represent the data. You can choose hex. This will change the representation into hexadecimal. Back to text, we'll turn it back to its original form, which was text. And here we get to choose how to treat the input. So do you want to decode, do you want to encode, or do you want to hash? Okay, sometimes you get confused as to what option of these is taking effect. It's actually what you choose that will take effect. So this is a sample ASCII text. If I choose encode, and here let's say base 64, this will encode this into base 64, and the output will be shown on the below pane here, or below workspace. This is the base 64 transformation of the original text. Again, we can do stacked transformation, meaning we can take the output of the first transformation and do another transformation, such as we can choose to decode it back into ASCII. This is ASCII hex, choose plain, decode as base 64. So here, as you can see, it's back to test. And then we can hash this maybe using MD5. So when hashing, you can see that the hash is directly or automatically popped using the hexadecimal representation. All right, but that doesn't serve me, right? Because you want to use the hash. What you're gonna do, you're gonna encode this as ASCII, or decode this as ASCII hex, not encode. That's not quite correct. Encode as ASCII hex. All right. So we choose encode as ASCII hex. This will give us the correct hash, or MD5 hash. You will do that only when you hash a specific string or a specific input. You have first to choose the hashing algorithm, and then you have to encode as ASCII hex to show the correct representation or the expected representation. Okay, what about the smart decode? The smart decode will auto decode or encode the given input based on a specific or a couple of algorithms, much like the magic feature in CyberChef. If you click on smart decode, let's take another example. Let's take this one here, and we'll choose smart decode. So it didn't work. Maybe we have to choose something similar to URL. Let's say we choose 2F smart decode. Okay, sometimes, yeah, so it worked now. As you can see, it gave me the /, which is the ASCII representation of the URL encoded format. Okay, now let's take practical examples. So practical example, we will do them as part of answering the questions of this room, BurpSuite other modules. Task 2, which feature attempts to auto decode of the input? It was smart decode. Base 64, encode this phrase. Let's start simple. I'm gonna take the input and paste it here. I'm gonna do base 64 encode. So encode as base 64. Okay, then What is the base64 encoded version of this text? It is this one. Easy peasy. URL decode this. I'm gonna URL decode this. So this is a URL encoded format. We want to URL decode this. We can choose smart decode, or we can decode as URL. So when you click on decode or encode, you choose the format from the drop-down list, which corresponds to the format of the given string. This is URL, so you choose decode as URL. Use smart decode to decode this. Okay. Click on smart decode and you get this. So you get two. First one is URL encoded and the last one is numeric. Encode this phrase, encoding challenge. Encode this as what? Start with base64, take the output and of this and convert it into ASCII hex. Let's start step by step. So first we encode as base64, so we click on encode and choose base64. And take the output of this, which is a base64, and convert it into ASCII hex. So we're going to convert this into ASCII hex. So encode as ASCII hex. Okay, finally encode the hex string into octal. Gonna click on encode again and select octal. It starts with 24 and we have the correct one. Now task 4, hashing. Using decoder, what is the SHA-256 hash sum of this phrase? Let's get hashing. Okay. So again, with hashing, we're going to select from the hash drop-down list and scroll down to SHA 512 or 256. It's 256. Yeah. So we get hexadecimal representation of the hash. This is not satisfying for most of the cases, so you want to encode. I always confuse this. Encode as ASCII hex, and we get the correct SHA-256 hash. Generate an MD4 hash sum of the phrase. Insecure algorithms. MD4. Who uses MD4 now? Insecure algorithms. We choose MD4 and encode as ASCII hex, and we get the MD4. Nope. Yeah, we did. Okay. Encode this as base64, not ASCII hex. Okay, so we're gonna cancel this. Oh, we're gonna, yeah, from here we encode as base64. So that's the base64 form of the hash. Let's look at an in-context example. First, download the file attached to this task. Okay. So we want, okay, cd or ls cd desktop and paste this query. Okay, now we downloaded the zip file. We're gonna extract the contents. And we have keys. Let's see what we need to do with these keys. Now read the problem specification below. Some joker has messed with my SSH key. There are 4 keys in the directory, and I have no idea which is the real one. The MD5 hash sum for my key is this. Could you find it for me? So basically, the owner of the key doesn't know which one is the correct key. We want to tell him which is the correct key by generating an MD5 hash sum for all the keys, and then comparing the generated hash sum with the given one. When a match is found, we're going to tell him, oh, we found your key. So we're going to double click on here and we're going to copy all of this. So this is an SSH key. Going back to Burp, select hash, MD5, and then encode as ASCII hex. We get the MD5. So the MD5 here starts with P72, but the given one starts with 31. So this means that key 1 is not the correct key. So what we're going to do, we're going to go and do the same with all the keys, generate MD5 hash sums, and you will find that key 3 is the one that has the same MD5 hash. Okay, now let's explore the other section, which is Burp Comparer. In Burp Comparer, we get to compare two given collection or group of words or paragraphs or even HTTP requests. We compare them using words or bytes, by words or bytes. As you can see on the right pane, the bottom of the right pane, compare, we choose words or bytes. We want to take a practical example. So we're going to, let's see if there's a practical example here. Compare overview, compare example. Yeah, we have one. We're gonna visit this page. Of course, we're gonna capture the request first with Burp proxy. Make sure it is on. And turn on the Foxy proxy, select Burp, hit enter, and now we have captured the requests. So how to send the request to Comparer? We're gonna highlight this. Right click, send to Comparer. Okay, we have one request now, right? Okay. Comparison is an operation that compares two objects. So we have one object now, which is the first request. What if we want to compare this into or with another request? So the given scenario here, in the repeater tab, change the credentials to. Okay, so here we want to simulate a request. So we're gonna go back and delete login request, sorry. We're gonna delete this by highlighting the entry and clicking on remove. I'm gonna forward this for now. Go back. First, we're gonna use test. Intercept is running. Okay. But still we cannot see the forward. I want to see the credentials highlighted, but looks like they don't show up. Test. Nevertheless, we're going to highlight this and send to Comparer. That's the first request. Okay. We're going to click on forward. Okay. In the other request, we're going to change the credentials. We used test in the first request. Now we're going to use maybe TryHackMe as username and password. Login. And we have another request. Going to send this to the Comparer, and now we have two objects, right? The first one with the test credentials and the other one with the TryHackMe as the username and the password. We can now start the comparison. We can choose to compare by words or by bytes. If you click on words, a new pop-up will appear, will show the differences. As you can see, the differences are categorized using colors, with the orange indicating the modified strings. So in the first request, we sent a GET request. In the next request, we sent POST request. And we have these highlighted in yellow. The yellow are the strings or the words that have been added to the original request. These ones were not found in the first one, so they were categorized as added. That's a word comparison. We can choose to compare using bytes, and we get a hexadecimal representation showing or showcasing the differences in hexadecimal. So that is the comparer. Questions to answer? I don't think there are. So now we move on to sequencer. All right, what's the purpose of Burp Sequencer? So in Burp Sequencer, we test the randomness of security tokens. Remember that cross-site scripting and CSRF attacks, they are successful, or attackers make them successful because of the lack of security tokens or because of an insecure tokens. If you want to test your CSRF tokens or XSS tokens, you want to use the sequencer. How to use the sequencer? We have two options. We can use the live capture, or we can use manual loading of tokens. So in manual analysis, we have, let's say you have a file that stores around 2000 tokens. You're going to paste them here and analyze them. Or if you want to do that with a live request, you choose live capture. But how do we do that? We're going to take a practical example. So we have this page, admin login. Let's first simulate a request to the page and find out if there's a token to this page. So admin login forward administration login. Let's try to log in with a sample username and password. Test. Okay. Okay, take a look at this. So we have these parameters. We have the cookie generated, we have the username, the password, and there is a login token. This is the usual token that protects the form from CSRF attacks. Okay, we want to test if this token has been generated securely. Okay, we will want to use the sequencer. What we're going to do then, we're going to highlight this and send to sequencer. In the sequencer, we see the request that we have captured. We're going to first need to highlight what we want to test. So here we want to use custom, and from the custom location we want to choose the token, but the token doesn't show here for some reason. And in the cookie, we only get to choose the cookie here. The token doesn't appear. Let's do that one more time. Admin. Let's highlight and send to sequencer. And now we have another request. But in both requests, we cannot see the option to select the token. Okay. Let's do this. Let's go back. And we're going to capture the request before we log in. Meaning we're going to capture the request with a login page. See if this will help. Okay. Fine. Now we're going to right click and send to sequencer. So we have a third request here. Yeah, this is the request. But this time we cannot choose neither the cookie nor the form field. Okay, so in the GET request we just sent, we can see the option to choose form field. Okay. We have the password, the username, and the login token. That's what we want. We're gonna choose the login token. So what worked here is the GET request. The POST request did not work to capture the token. So maybe you can take a note of this for future scenarios. After we specified what is the token to be tested, we can start the live capture. BurpSuite will attempt to analyze the given token. At the same time, will simultaneously send thousands of requests. It will send thousands of requests literally to the application, testing different tokens. After testing around maybe 10,000 tokens, BurpSuite can give us a report indicating the level of entropy and randomness of the token generated. When this is finished, you can click on Analyze Now. At the end, there is a report. The most important section of the report is this, the overall result, which gives us a broad assessment of the security token generation mechanism. So here it is stated that the overall quality of randomness within the sample is estimated to be excellent. At a significance level of 1%, the amount of effective entropy is estimated to be 119 bits, which is relatively very high according to this scale. So right here in the effective entropy, the chart shows the more we go on the number of bits of the entropy, the higher the entropy or the higher randomness is. So above 120, this means that the randomness is very high or the entropy is very high, and therefore the tokens must have been generated very securely. That's what we can take away from this report. Okay, other questions to answer. What is the overall quality of randomness estimated to be? It was estimated to be excellent. Nothing to answer here. The organizer overview is very easy, guys. It's just to organize your workflow in BurpSuite. And this will conclude these rooms.